In the previous videos, section 14.2, I indicated I probably want to do just one more of these things. This is in fact question 5 on page 198. Now I took the liberty of doing some preparation earlier, and I've begun to plot the axes and plot the points required. And here's a lovely parallelogram. It says draw a pair of axes for values of x from -2 to 12, so I've gone from -3 to 12 naturally, and y values from -4 to 6, and so I obeyed that one. I couldn't bear having a 2 there, it looks a bit too cramped, so that's essentially what I've done. Plot and label the parallelogram ABCD with these vertices, so A, B, C, D, that's the order in which they were given, and that's the order therefore in which I've labelled them. So ABCD, that's a lovely parallelogram. It says draw the image of ABCD after an enlargement to scale factor 1/2 with centre -2, -4. Okay, so let's first ID this centre. -2, -4 is right there. Now remember the trick, you try and pass through each vertex provided it doesn't get too messy, and then we just extrapolate backwards, if I may use that fancy maths word, extrapolate. So let me just do that. Again, very hard to tell, it's very what's the word, delicate. That's the best I can do at the moment. As you can see, it's made a real mess of it. Anyway, enlargement, scale factor of 1/2. Now, let's take a look. If I want to look at this point here, point A, which is originally 6 minus 1, if I want to halve it, let's have a look. 1, 2, 3, let's go back to black or something. If I want to go from there to A, I go 1, 2, 3, 4, 5, 6, 7, 8, and 1, 2, 3 up. Okay, so 8 across and 1, 2, 3 up takes me to point A. If I'm going to enlarge by a scale factor of 1/2, I need to halve the direction in the x and the direction of the y. So half of 8 is 1, 2, 3, 4, and half of 3 is 1/2, and it's right there. Can you see that? So 1, 2, 3, 4, 1 and a half. And look, if you look very carefully, that construct line passes through that point and the point A. I've tried very hard to make it look right as well. Okay, so that's really tricky. Now that's that one. Next one, let's look at D. Do it mathematically. 1, 2, 3, 4, 5, 6, 7, 8. So it's 8 across, and up we go 1, 2, 3, 4, 5, 6. Now if we halve it, we can go 4 and 3. 1, 2, 3, 4, 1, 2, 3, and it's right there. Again, very difficult to actually draw accurately, especially on a computer like this. So I've got point A, which is the image, well, it's the point A dash actually. So that's A dash, the image of that point there, A. That will be D dash. I can't dare label it because there's too much going on there. That's the image of point D. Now let's just do the C, shall we? C goes 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So it's going to be 6 across when I enlarge it, scale factor 1/2. Now up we go 1, 2, 3, 4, 5, 6, 7, 8. So half that will be 4. So we're looking at 1, 2, 3, 4, 5, 6 across, and 1, 2, 3, 4 up. And here is my point C on the point 4, 0. And it's really, really hard to see. I'm sorry. Now let's just do B. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 12 along. And B is going to be 1, 2, 3, 4, 5 up. So half of 12 is 6, and half of 5 is 2.5. So I'm going for 6, 1, 2, 3, 4, 5, 6, and 2.5. 1, 2.5, and there it is, right there. That's as accurate as I can possibly do it. Now I need a nice bright colour for this to stand out against all this busyness that we're doing, just to join these things. So that to that in yellow. It won't look brilliant, and it's even hard to draw it. That to that, and that vertex to that vertex. Far from perfect, much easier on paper, plus it's a rather difficult question anyway. So let me try and label these for you. Let's go for black anyway. So if that's A, this one would be A dash. If that's B, the corresponding point will be B dash. As you can see, I'm trying to get out of the way here. That will be C dash, that one right there. And this one will be D dashed. Alright? And I won't try and drag these labels any closer to the actual vertex they relate to. But that's it. The next part's going to be really difficult to try and do on screen, so I'm going to talk you through it anyway. But just accept that that's half the size of that one. That's A, B, C, D, and that's A dash, B dash, C dash, and D dash. All right, and that's that. That's the hard part done. Now C says, what are the coordinates of the vertices of the image? Well, I spoke it through as I calculated them mathematically. So, for example, the original A is 1, 2, 3, 4, 5. Sorry, the original A is 6 minus 1. So I went 1, 2, 3, 4, 5, 6, 7, 8 across. So half it is 4, and 1, 2, 3 up. Half it is 1.5. So A is going to be 4, and it's going to be, let's have a look, 1, 2, 3. Oh, sorry. I mean, it's 4 units across, but the coordinate's going to be 2 minus 2.5. So 2 minus 2.5. Alright, just check it. 2 along, 1, 2, and a half down. That's correct. Not very clear. I'm very sorry about that. That's the best I can do. Now, what about B then? Oh, really hard to tell. 4 across, clearly so. 1 and a half down. So 4 across, comma, minus 1 and a half. Now, what about this C dash thing? Well, C dash is right there on the line, which is mercifully quite easy. That'll be 4 along, 0 up, so it's 4, 0. And this one I'll try and fit there, bit luck. So 2 across and 1 down. I think that's correct. That's going to be 2 minus 1. Alright, so that's my calculations and my working done, I think. Yeah, I'm going to stick with that. That's what I make it. So now it tells me to do something quite impossible on a grid like this. It says measure the diagonals AC. So I'm supposed to measure from there to there and measure the diagonal A dash C dash across there. Well, I really can't do that. I can't do that. What do you notice about the lengths? Well, it's an enlargement scale factor of half. So what can I say? If they ask me to measure from B to C, I'm going to say 1, 2, 3 units. If they're going to get me to measure between B dash and C dash, I'm going to say 1.5 units. So what's happened? What do you notice about these lengths? I'm going to say that A dashed C dashed is half the length of AC. Alright, not difficult to understand that, because it is in fact an enlargement to scale factor 1/2. Therefore, the length of the line A dash C dash, which is the image of the line AC, will be half the length of the line AC, because all the lengths get reduced down to half the size of the original object rather than the image of the enlargement, which happens to be a shrinker. Think about the word shrinker. Still call it enlargement. Don't call it shrinker, please, whatever you do. But if you think of it as shrinking down, that would help you to halve the lengths rather than double them and get the working the wrong way around. What do you notice about the lengths? Let's just write it here. All the lengths in the image A dash, B dash, C dash, that's meant to be a D dash, are half the length of the corresponding object. And the object is what? Well, A, B, C, D. Alright? All the lengths in the image A dash, B dash, C dash and D dash are half the lengths, half the length of the corresponding object lengths. That's better. The corresponding object lengths in A, B, C, D. So, yeah, as clear as I can do it, really. Now repeat the process for B, D. Oh, great. Now B and D, that's that diagonal, and B dash, D dash. I'm not going to do that. Relate your findings to the scale factor. Well, I've really answered it right here, haven't I? So I've really combined all this part here, D's, E's and F's. They all combine into this sentence right here. Hopefully you can see that, and I'm not in the way too much of this little description. But there you go. The maths make sense, the diagrams make sense, the corresponding lengths will be in the correct scale factor, whether you reduce it down or scale it up. And that's all there is to that question. So that's the end of 14.2. We're now going to go grade A very soon. Alright?